Hello. Shall be doing Chem and it's on can't write. Intermolecular forces. Let's see my mic, yeah. Wait, let me just fix my mic a bit. Yeah, it should be better now, I think, hopefully. Um I'll do two questions. The first one says that list the following substances in order of increasing boiling point and justify your choices. And part A. This is just the general information we should know from this topic. This is the substances we have to list in order. So first, let's see, there's three types of bonds, right? So there's dispersion, dipole, and also hydrogen bonds, right? Hydrogen bonds. So first, let's start a periodic table, right? Hydrogen bonds only happen with a hydrogen and also a nitrogen, oxygen, or fluorine. So let's check if it happens here. We have a fluorine with a hydrogen. So that is a hydrogen bond. Let's write actual working out. So HF have hydrogen bond. And that means that it will have the highest boiling point. And then we have Cl, Br, and iodine. So these on the periodic table are in the same group. So that means that chlorine will definitely have the highest electronegativity, which makes it have a higher boiling point. But iodine have a way higher amount of electrons. They have 53 compared to chlorine's 17 or 54 if it's forming a shell with a hydrogen. So that just means iodine, hydrogen iodide will have a way higher dispersion force. So these three we can just order them in order, yeah. So so electrons. So the dispersion. So the dispersion forces of Hi, HCl, and HBr will be in order of iodine first, because iodine highest. So Hi will be the highest because it have the most electrons. It will have the most dispersion forces. And then it will be HBr, and then it will be HCl. And we have to do it from the question asks us to list the substance orders of increasing boiling point. So increasing boiling point order. That means I have the lowest, so it's HCl, HBr. Yeah, let's do it like that. HI, and then it's HF. Yes, that should be right. Yep. And then we do part B of this question, and that asks us to put H2O, NH3O2, and CH3Cl in order. Okay, so first let's check our three different types of intermolecular forces first. So we have the hydrogen bond. So let's check hydrogen bonds. We need nitrogen with a hydrogen, oxygen with a hydrogen, or fluorine with a hydrogen. So see, we have oxygen with a hydrogen. So that's hydrogen bond. Nitrogen and hydrogen bond. Oxygen only doesn't have hydrogen, not hydrogen bond. Carbon, chlorine, hydrogen. That's not hydrogen bond. So these two will definitely have the highest boiling point. So we'll put hydrogen bonds. So we have H2O and NH3. So first, oxygen have a higher electronegativity, which means that it will hold on to the hydrogen harder, and it will pull on the other hydrogen from another H2O harder, making it have a higher uh, intermolecular force and making it have a higher boiling point. This will be higher, this will be lower, because it'll have a lower electronegativity. Lower electroneg. I ain't writing the whole thing. Oh well. And then now we have two left, yeah. So first they will both have dispersion forces, but let's check dipole-dipole. Dipole-dipole requires the substance, the molecules to be not symmetrical. Let's look at O2 first, yeah. O2 is O is A. It have 6 valence electrons, so it's 16. So that means it have 2 bonds. So it's like that. 1, 2, 3, 4, 5, 6. Yep, that's right. So it will look like this when it's bonded. And we can see there's a clear symmetry right here. So this is symmetrical. And so that means no dipole force. And let's look at CH3Cl. How would this work? So we have carbon here, have hydrogen, we have chlorine. I think that's how it works. And this will be in a tetrahedral form. So if you so that means this will have that much electrons, while the other ones only have they have no more. So this is clearly not symmetrical. So this is clearly not symmetrical. That means it has dipole-dipole force, which means that this will have a higher boiling point. Lower. That means the order, so it is the increasing boiling point order. Increasing boiling point order will be lowest. Yeah, lowest will be O2, and then it will be this thing, so CH3Cl, and then it's the 2 hydrogen bonds, so that is H2 and NH3. H2 have higher ones, so it's NH3 first. So it's NH3, H2O, and that's the order for this question. And now we move on to question 2. No, 6. Where did I get 6 from? We have to predict the solubility of each of the following substances in hexane, a non-polar liquid, and explain your decisions. Okay, so now we know that it's in hexane and it's non-polar, and that means it's soluble. So other non-polar substances are more soluble. And let's look at part A. Part A asks us methane. Methane is CH4. We all know what it looks like from organic chem. It's just a C in the center with 4 H's surrounding it. It clearly has symmetry because and all of the charges are the same. So it's clearly non-polar. So HC4 is non-polar, and that makes it have a high solubility. That was asking? Predict the solubility, yes. And for part B, we have ethanol. Ethanol is a ethane, but with a OH at the end. So one end will have a OH, the other end will have a H, making it polar because the two different sides will have two different charges and one have more electrons. So that one will be more negative and the hydrogen side will be more positive, making it polar. So we're gonna write H2 C2H5OH is polar, low solubility. What? Solubility. For part C, we get ammonia. So NH3. NH3, right? Nitrogen have five valence electrons, and with three from hydrogen, we are still three from hydrogen. There will still be two left on the nitrogen. So that means it'll look like an N with three H's, while the N still have like two. I don't know how many there. There's still some electrons here, making this polar. So ammonia NH3 is polar. Which means it have low solubility. For part D, we have hexane. Like, bro, hexane is in a question. So hexane is definitely, we can say it's non-polar. That's why it's soluble. It's definitely soluble in hexane. So very soluble, very high solubility. For part E, we want iodine. So I2 is the same as O2 as we said before. So I2 is obviously symmetrical. Symmetrical means that this is non-polar. So I2 is non-polar, making it have high solubility. And for E, we have F. F says glucose. Glucose is H6, C6, oh my god, C6H12O6. That is a very weird substance. It says C figure 19.1, but in our questions we don't have anything. We don't have a diagram showing us what glucose looks like. So let's just pull up. What does it look like? So basically, it's basically a structure like this. So it looks like a OH, C, 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 O, OH, 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 OH. Let's count 1, 2, 3, 4, 5, 6. 6 O's, hydrogens 1, 2, 3, 4, 5. And because there'll be a H here, H here. Okay, there'll be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 H's. We just don't draw the ones that's sticking out here because there will definitely be one because hydrogens have 4 bonds. And let's see, 1, 2, 3, 4, 5, 6. 6 carbons. This is a valid structure. And we can see that there's double bonded O here. There's an OH here. They obviously don't have the same charge or the same electrons. So we're making this definitely polar. So let's just leave that working out. It's polar. So that means it have low solubility. And that is it for the chem questions. Thank you for listening. Bye bye.